So using percentages. This presentation is designed for those people for whom the statement is not obvious. So last year we had 200 customers per day, but we expected growth this year to be 7%, so that we were planning for 214 customers a day this year. Now I assume you learned percentage in math, and you're also probably familiar with the method for calculating percentages, which is take your answer and multiply by 100. And the issue here is, what does this all mean? Because mathematically speaking, it's not very difficult, but we need to feel comfortable with it. So a bit of background. The word percent actually comes from Latin. Percent equals per centum, or per hundred. Probably in traditional Latin, per centum. I'm not familiar with Latin. I didn't learn it in school, and I always thought it always came from French, because cent, C-E-N-T, is 100 in French. But it turns out that it's from Latin. Now, it's a way to describe fractional values, that's all. In other words, numbers less than 1. So percentages are just simply a relationship where something represents 100%, and that means the whole, or 1, and any percentage below 100 is that fractional amount. So here's an example modified from Wikipedia. So 60% of all students are female, and 12% of all students are computer science majors. Now, if 55% of the female students are computer science majors, what percentage of computer science majors are female? Now that's kind of a math question, and it's not so easy and so obvious. I'm not going to answer that here because we're not doing it's not a math presentation, but if you wish, you can provide your answer, and we'll see how it goes. Now, translating percentage. Let's take an obvious example to calculate a decimal to a percent. So what percentage is equal to 1/2? Now you may know that already, but let's go through the process. So 1/2 is 0.5, and using the rule we learn in school, multiply by 100, and then you have the percentage. So 1/2 times 100 is 50. That means we have 1/2 is 50%. A percentage is simply a number. It's the percentage sign is not a unit. It's not like kilograms, liters, kilometers, anything of that sort. In many cases, the percentage figure will be a value between 1% and 100%. So examples would be 39% or 4.67%. These numbers represent fractional hundredths. That's why we translate percentage into the usual numbers by dividing by 100. So 39% would be 0.39, and 4.67% would be 0.0467. We run into unusual percentages, so some that are unusually high or low. So for example, we'll have 0.072% or 6,320%. These numbers are still fractional hundredths, and to translate them into normal numbers, you can always remember that you can consider any number as having a number of zeros on either side of it, to the left of the number and to the right of a decimal space. So 82.3 is 0 thousands, 0 hundreds, and 82.3. And similarly, 6 is 0 hundreds, 0 tens, and 6, so 006.00. And again, I've added also a couple of zeros on the other side of the decimal place. Therefore, turning unusually small or large numbers into percentages, or from percentages into numbers, is a matter of shifting the decimal place by 2 spaces. So let's take a look at our 2 examples, 0.072 and 6,320%. Now in the first case, we have to rewrite the 0.072. We're adding a couple of decimal places to the left so that we can take this decimal place and move it over 2 spaces, and then we'll end up with 0.00072. So that's what 0.072% represents. Now in the case of 6,320, the decimal place is automatically after the whole number. So moving two spaces here brings us to 63.20, which of course is also 63.2. In the case of large numbers, of course, the issue is more turning the number into a percentage. We may have to add a zero at the end, as is in this case. We would have 63.2. We would have to add a zero here at the end to, whoops, that was a bit of a messy zero, but you see what I mean. And then we'd shift that over by 2 spots to get the 6,320. So note, because the percentage sign does not represent a unit of anything, it's not simply added at the end of any kind of a calculation. Let's take an example here. Out of finance, we have debt equity ratio, and given the debt is 300 and equity is 400, how do we calculate it? Well, debt equity ratio, you can kind of guess maybe that it's debt divided by equity, and that would be correct. So you take 300 divided by 400, and the answer is 0.75, which is also 75%. Just keep in mind, so the answer is not 0.75 and then you add a percentage to it as if it's a unit. Yeah, percentage is just a way of representing a number, and so basically it's 75%. And coming back to the example that I mentioned in the notes to this presentation, let's take a look at adding 1 plus 6.5%. So 1 plus 6.5% is 1.065, because 6.5% is just a way of writing 0.065. By the same token, if you want to write it as a percentage, here you're shifting this over 2 decimal places, you have 106.5%, because 1 is equal to 100%. So 100% plus 6.5% is 106.5%. Anyway, what's important is you're not going to add the 1 and the 6.5 and then slap on a percent there. So it's not 7.5% and it's also not 7.5. So that's it for this presentation. Thanks for your attention, and I hope that helped.